All right, welcome to our 7.2 part 2 lecture. I always like to break up 7.2 into two separate lectures so that we get a lot of practice, a lot of different examples that we can do either together as a class or on IXL or just some extra problems that I'll throw up on the board. So if you ever have any additional questions on 7.2 or would like to be pointed in the direction of some additional IXLs, I have on Google Classroom a listing of other IXLs that you can practice for this. There's also a couple of maze worksheets that are up there that you can utilize. So always ask if you're interested in additional practice problems. So today our learning target is going to be to simplify radical expressions. So we're going to simplify expressions that we're going to start with having a variable. There's going to be also some roots, right? Unfortunately, we're not going to be only working with square roots. Sometimes we will be working with square roots, but we have to consider different nth root categories that we need to utilize as well. So here, what I have is we're going to get started with kind of simplifying some expressions, and there are two specific strategies that you can use. And I encourage students to kind of use whichever one they like the best. And I promise I will show you each of those strategies as we go through some of these examples together. So I'm looking at my first example here that says the cubed root of y cubed. Now, in general, when we take the square root of a number, say the square root of 9, right? We know that that's 3. But why is it 3? Well, the reason being, because I know it's probably been a long time since we realized why, is there is this little 2 that's in here, right? It's not listed, it's automatically implied when you see a square root. But what this means is you try to think to yourself, what number times itself, right? Times itself 2 times is going to give you the value that's under the radical. And so when I kind of break out 9 as 3 times 3, I can say, okay, I have 2 3's under here. So that tells me the square root of this number is just the number 3. So for every 2 numbers that I have under the radical, 1 comes out. And that type of strategy is kind of the first strategy that I'm going to show you here. Now I have the cubed root of y cubed. So I have the cubed root, and if I want to kind of write it out in the same way, I have y times y times y. And my root, my index value here, that tells me how many of the variable I need in order to bring one out. Since my root is 3, I need 3 y's in order to bring one out. And since I don't have any extra y's under the radical, my answer is simply that. The cubed root of y cubed is y. Let's look at a similar example down here. Now I have the 5th root of d to the 6th. So I'm going to write it out again. And like I said, this is our first strategy. 3, 4, 5, 6. This tells me in order to bring 1d out of the radical, I need 5 d's. So I circle those 5 d's, and that tells me, okay, I can bring 1d out of the radical. What I have left inside the radical is 1d left over. So I keep my index value, and I wind up with d times the 5th root of d. This is as simplified as it gets. You cannot simplify down any more than that. Now let's look at this next example. For this next example, don't really want to write out 12 y's. I could, right? I could use the exact same strategy, but what I want to show you is the alternative strategy that you can use for these. And some students like this, some students do not. Do we remember back to our old mixed numbers? How do I write, a mixed number, something like 2 1/3? That's an example of a mixed number. So what we do is we rewrite this in exponential notation. When I do that, right, the index number here is my denominator, and I have a 12 on top. Now in this case, 12 divided by 3 is just 4, so I wind up with y to the 4th power. Can't really simplify more than that. I am done. Now let's look at this example down here. I am going to rewrite it as x to the 12/8 power, right? Whatever my index value is, that is my denominator. Then I say to myself, okay, how can I simplify down 12/8 and rewrite it as a mixed number? So I have x, so 12 divided by 8, I have 1 and 4/8 left over. Now, can I simplify 4/8? I can. I have x to the 1 and 1/2 power. So here's what I do. I've got a whole number 1 and a fractional value of 1/2. So I like to kind of break that out this way, x to the 1, x to the 1/2, just so I can see it. Because if there's a fractional exponent, that tells me that's the radical part, and this part here is outside of the radical. So when I come back and I rewrite it, now kind of like in our last lecture, I talked about how if you start with a radical question, you have to finish the question as a radical. So I would have to take this value here and rewrite it like this. Now, if you need to put a little placeholder of 2 in there, especially as we're, first getting through this unit, go right ahead, but know that just with a square root, the 2 is implied there. And that is as simplified as that example gets. Let's look at some more examples. And I encourage you to definitely pause the video and choose whichever strategy you like the most, whether it's writing out the letters and then circling them, or doing it the way that we just did with the mixed number practice. So when I look at this one, really doesn't matter. Maybe we'll do a couple each way, right? Why don't we do a couple each way just like we did on the previous example? So let's do the mixed number way on this one. I like to do the mixed number approach if I know I'm going to have a fraction that I need to simplify down. So I have z to the 6/4, which if I write that as a mixed number, I have z to the 1 and 2/4, which is z to the 1 and 1/2. The whole number part, that's outside of the radical, and then the 1/2 part, that's under the radical. So I get z square root of z. Right, let's look over here at this example. Let's do the same thing. We'll do the mixed number approach. So I have a to the 10/5 and b to the 18/5. Well, 10 divided by 5 is just 2, so I wind up with my a's are all out of the radical, right? 10 is easily divisible by 5, so we can see right away, oh, that's nice, that will be simplified down. Whereas my b value, right, I get b, and then how many b's that do I have, right? I have 3 that can go into 18. 18 divided by 5 is 3, and 3/5 left over. I cannot simplify 3/5 anymore, but if you'd like to write it again, right, these are the two things that have whole number exponents, so they're outside of the radical, and then I have b to the 3/5 that is under the radical. So when I come back up here and I write it as a radical example, I have a squared, b cubed, and then the 5th root of b cubed. I know, pretty ugly, right? This is a very algebraic process. There is not a whole lot of real-world application that I can go through with this. This is just preparing you for higher level math and really, at this point, stretching your algebraic skills. On our next two examples, why don't we do the other approach where we kind of write it all out? So I have the 4th root of, I'm going to write out 9x's. So I have the 4th root of x to the 9th. So I circle my first 4 x's. I circle my next 4 x's, and I see that I have another x left over. So that tells me that I get to take out an x and another x. So I have x squared, and I'm left over with the 4th root of x underneath the radical. This example here, I have 9 a's. I say, okay, now what is the index value here? Remember, it's a square root, so the implied number there is 2. So I go ahead and, circle 2, circle another 2, third 2. There we go. So I can bring out 1, 2, 3, 4. I have a to the 4th that I bring out, and then I'm left over with 1a under the radical. Right, let's move on to our next example here. Now we're going to get into we're going to put a lot of stuff together. We have 6 examples to get through where it's a little bit more of heavy lifting, right? It's not just one variable that's under the radical. It might be multiple different variables under the radical that we need to work with. Here's what I recommend. There's a lot going on in this problem. I recommend to students, let's go ahead and kind of break out each section, okay? Let's simplify each letter one at a time, and then we'll come back and we'll put all of our answers together all at once. So the 4th root of 625 is 5. It is outside of the radical. There is no more numeric value that is under the radical. The 4th root of a to the 12th power, that's a cubed. The 4th root of c to the 5th, that's c, 4th root of c. And then the 4th root of b to the 20th is b to the 5th. So when we come back and we put all of this together, if it started in the numerator, it ends up in the numerator. If it started in the denominator, it winds up in the denominator. So I have 5a cubed c 4th root of c all over b to the 5th power. Question letter B. I am doing some subtraction here, and if we remember from our last lecture, 7.2 part 1, in order to be able to do that subtraction, I need exactly the same radicals. And unfortunately, these radicals are not the same right now. So that tells me I'm going to have to simplify each of these radicals down and hope that I wind up with 2 similar radicals that I can do the subtraction. Now this is a square root, so the implied number there is a 2. So I have the square root of 9, well that's 3. The square root of x to the 5th, that's x squared, square root of x. Over here, I've got the x already on the outside, but I need to simplify, I'll do it down here, the square root of x cubed. That's x, square root of x. So I'm going to come back up here and I'm going to rewrite this whole problem. I kind of know exactly what the front part is of this subtraction problem. I have 3x squared, square root of x, minus, and here's what I encourage you to do. You've got this x that was part of the original problem. Now write the simplified. And notice I put a little multiplication symbol in there, right? What I'm doing here is I'm saying, I know that what's going on between here, even though there's no multiplication dot, that these two things are being multiplied together. So I get 3x squared, square root of x, minus x squared, square root of x. And look at that. We have like radicals. We also have like terms, right? X squared and x squared. And if you need to, right, 3x squared minus x squared, well, there's a 1 there. So I get 3x squared minus 1x squared, 2x squared, square root of x. Final answer. Right, next example here. We have the 7th root of p to the 8 divided by q to the 21st. So just like our letter A example, you know what I'm going to do is I'm going to do these one at a time. And then I'm going to come back to my original problem and say, okay, what ends up in the numerator? What ends up in the denominator? So for this one, I'm going to simplify my 7th root of p to the 8th. So 1p comes out, and I'm left with 1p under the radical. Here, I just get q cubed. I come back to my original problem, whatever started in the numerator, my p is the one that started in the numerator, and my q's were in the denominator. Final answer cannot be simplified more than that. We have 3 more examples to do, so let's go ahead and move on. So now I've written this example. Instead of it being in radical form, it's in rational exponent form, and they mean the same thing. Similarly, with some of our first examples, notice, right, I'm multiplying these 3 things together. So that tells me I can kind of bring that 1/5 power in. Just a different way to think of it. If you would rather write this as a radical and go through the similar approach that we did for A, B, and C, you definitely can. But a little bit of a, well, maybe not a shortcut, just a different way to think about it is I'm going to kind of bring it in to each of my terms that's within this expression. So I get 32 to the 1/5, m to the 5th raised to the 1/5, and n to the 30th raised to the 1/5. And I've got to remember those exponent rules. Now 32 to the 1/5, that's just the number 2. If I have a power raised to another power, I simply multiply these 2 things. 5 times 1/5 is 1, so I get m. If you want to put the placeholder of 1, that's fine. And then 30 times 1/5, that's 6. So there we go. Cannot be simplified more than that. Ooh, goodness gracious here. Well, I'm subtracting, so this kind of aligns to the earlier or the previous learning target that we had with 7.2, adding and subtracting. I look and I have exactly the same radical here. Now, the 4th root of p cubed, that cannot be simplified, right? That is already as simplified as it can get. In order for 1p to be able to come out, I need to have 4 p's under the radical, and I don't. So all I really need to do is remember those adding and subtracting rules that tell me subtract your outsides and keep the insides. So I have 2/3. Let's just remember some fraction math, minus 5/3. When we subtract fractions, subtract your numerators, keep your denominators, and then simplify if possible. So I simply wind up with -1 4th root of p cubed. And you don't even really need to write the 1 there, right? That's kind of a placeholder. You can simply write it like that. All right, our final example for this lecture is we have the exact same thing here. We have exactly the same radical, which is the b portion, and then I have like terms. I can add and subtract a's together because they are like terms. And if you want to rewrite this problem as a radical, go right ahead, right? If it helps you to kind of keep that straight, go right ahead and write it that way. But since we started with the exponential question, we're going to end with an exponential question. So I simply have to subtract my outsides. 4a minus 12a is -8a, and then I keep the radical exactly as is. So this one didn't require that much work as long as we saw right away that we have like radicals and like terms on the outside. This kind of ends 7.2. I would highly encourage you, if you're looking for some additional practice, under IXL, now switch. Last section we were doing Algebra 1. This section is Algebra 2. Try M4 or M5. I just wrote and, but really it can be either or. They're very similar. In fact, I think really IXL, just like probably other teachers across the country, we're really just trying to put as many different algebraic examples out there for you to practice, because really these types of skills is just skill and drill. Can you practice it, practice it, practice it till you get it down? So there's both M4 and M5 that is simplifying radical expressions that I would encourage you to do. Your homework assignment is in that packet of worksheets. It is simply just the 7.2 worksheet. Thank you for your time again. Have a good one.